Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So the problem is given as you are given an array, and in this array all the numbers are appear even numbers of time except the one number that appear odd number of time. So let's understand this with an example. So let's say this is an array, and this array contains elements like 1, 1, 2, 3, 3, 3, 3. So in this array 1 appears 2 times, 2 appear 1 times, and 3 appear 4 times. So 1 and 3 appears even number of times, and there is only one element that appears odd number of time, and that is 2. So the output of this input is 2. Let's see other example. In this array the elements are 2, 2, 3, 3, 3, 9, 9. So 2 appears 2 times, 3 appears 3 times, and 9 appears 2 times. So you can see clearly that 2 and 9 appears even number of times, and 3 appears odd number of times. So the output of this input is 3. So now let's pause this video and think about a solution to solve this problem. So let's discuss brute force approach to solve this problem. So the idea is simple. We pick one number at a time, and then we simply count number of occurrence of that number in the given array. And as soon as we find count as odd, we simply returns and say that this number appears odd numbers of time. So we were always given an array such that all the numbers are always appear even numbers of time except only one number that appear odd number of time, right? So let's see how we implement this idea in code. So this is the implementation of the idea discussed above. So we have a function find odd occurring number, and this function is accepting an array. So we are running a loop from 0 to less than array.length. If the array has 7 elements, then we are running a loop from 0 to 6. And then we initialized a counter to 0. Then we again running a loop from 0 to 6, and we check if array of I is equal to array of j or not. If it is equal, then we simply increment the count by 1, right? And after inner loop, we are simply checking if count is divisible by 2 or not. If it is not, then it is a odd occurring number, and we simply return that number. So the outer loop takes one number at a time, and inner loop checks that number in entire array. So let's quickly dry run this code and see how it works. So let's say the array is given as 1, 1, 2, 3, 3, 3, 3, and here size of array is 7. So in first iteration the value of I is 0, and the value of a of I is 1, right? So we count number of occurrence of number 1. So we get 2, and this is a even number. So we simply continue to next iteration. In next iteration our I becomes 1. So the next element is again 1. So again we count number of occurrence of 1, we get 2. And this is an even number, so we simply continue to next iteration. In next iteration, means third iteration, the value of I becomes 2. And the value of a of 2 is 2. So we simply count the number of occurrence of 2 in this array. So this time we get count as 1. And this 1 is a odd number, and this time we hit this condition and we simply return element 2. So 2 is the odd occurring element in this array. Talking about the time complexity of this function, how many times outer loop is running? It is running n times, and in each iteration of outer loop, inner loop is also running n times. So the overall time complexity of this function comes out to be n into n, and that is equal to big of n square. Okay, so this is a quadratic order of growth, and generally this order of growth is not considered as best order of growth. So can we do it better? Do we have any other way to solve this problem? Can we solve this problem in less than n square time complexity? Yes, we do have other approach to solve this problem, and this is where XOR come into picture. Now let's quickly see the truth table of XOR. So when two operands are 0, it gives 0, and when we have alternating operand, it means one is 0 and one other one is 1, it gives 1. Okay, and if both the operands are 1, it still gives 0. So the XOR returns 1 only if we have alternating operands. If first operand is 0, then it is must to have second operand as 1. And if first operand is 1, then it is must to have second operand as 0. So in those conditions only, XOR returns 1. So let's see a few of the properties of XOR. So let's see the commutative property of XOR. So commutative property of XOR says if A XOR B is equal to B XOR of A. So let's say we have a number A and whose binary representation is 0101, and we have B whose binary representation is 1010, and we do XOR of A and B, we get 1111. So as per this property, if we do A XOR B or B XOR A, in both the cases we get the same result. Now next property is associative property. It means if we do A XOR B XOR C, then it is equal to A XOR B XOR C. Okay, you can do it yourself and check if it definitely works. So see, the next property is XOR is a self-inverse. It means if there is a number A and if we do XOR with A itself, then we get 0. So means if we do XOR, so it means if we do 1 XOR 1, we get 0. If we do 5 XOR 5, we get 0. If we do A XOR A, we get 0. And the last property is 0 is the identity element for XOR. It means if we do A XOR 0, it gives A. So 0 is going to be its identity property because it is returning A. So we are going to use these two properties to solve this problem. So let's say we have three numbers 2, 2, 2 and it appears odd times. So what happens when we do XOR of these three numbers? So when we do 2 XOR 2, it gives 0, and then if we do 0 XOR 2, it gives 2, right? So what happens when 2 appears even times? So when we do 2 XOR 2, by using self-inverse property, it returns 0. Moving on. Now let's say we have an array of elements and we have to find odd occurring of number. So what we do? We simply XOR all the elements. So let's see what happens when we do XOR of all the elements. So first we do 1 XOR 1, it gives 0. So which property it is using? It is simply using inverse property, right? Next we do 0 XOR 2. Now this time it's going to use identity property because 0 is the identity element, so it returns true 2. Now next we do 2 XOR 3 and it simply returns 1. Okay. Next we do 1 XOR 3, then it returns 2. If we do 2 XOR 3, it returns 1, and if we do 1 XOR 3, it simply returns 2. So the result comes out to be 2, and 2 is the odd occurrence in this array. So this is how XOR helps us to solve this problem. So let's see the implementation of this idea. So here you can see the simple implementation of this approach. We are simply running a loop from 1 to less than array length, and we are doing XOR of all the elements present in the array. So we are storing the first element of array in the result, and then we are running a loop from 1 to less than equal to array.length, and we are doing XOR of all the elements. In the last, we simply returning result. So let's say we have an array of all the elements 1, 1, 2, 3, 3, 3, 3. Using this function, we XOR all the elements and we get output as 2. Now talking about the time complexity of this function, how many iterations this function is going to have? There are total n iteration because we are running loop from 1 to array.length. So the time complexity of this function comes out to be theta of n. Okay, clear. So let's have a quick recap of what we have learned so far. So we are given an array with elements, and in that array all elements appear even number of time except one element that appears odd number of time, and we have to find that element. So we saw the brute force approach to solve that problem, and the time complexity of brute force approach came out to be theta of n square. Then we saw efficient approach to solve this problem using XOR operator. And the time complexity of this efficient approach comes out to be theta of n. And this time complexity is much better than quadratic time complexity. So this is it for this video. Thanks for watching. See you in the next video.